Hello, algebra students. Welcome to virtual GED class. Today we are going to continue multiplying. It's like we're multiplying and multiplying forever. Last lesson on this before we put it all together. But we are going to be multiplying what we call polynomials. Don't worry if that sounds hard. It's not nearly as challenging as it seems. We've got a student here with us. Miss Annette is going to keep me in check, make sure I'm making sense. All right, let's get going. So first of all, I just want to make sure that you remember all the simplifying we've done so far in algebra. So we've practiced adding and subtracting. Let's look at this first little review example, 5x plus 4x. Miss Annette, do you remember how to combine like terms, which is what we call addition and subtraction in the land of algebra?
That is 9x.
Beautiful. Just like 5 xylophones and 4 xylophones would be 9 xylophones. 5x and 4x's is 9x's. And once again, I have no idea why I own so many xylophones. Okay, next example. Now we don't have a plus sign. This has a different operation going on. Could you read the next expression for me?
5x times 4x.
Brilliant. Now I'm not adding. Now I'm multiplying. I have to be able to flip into that process. Any thoughts?
5 times 4 is 20.
Beautiful. Coefficients come first. We multiply together the 5 and the 4. Then what?
Squared.
Wonderful. We don't just have a single solitary x multiplying. We have 1, 2. And so we will use exponents to talk about repeated factors. That's 20x squared. Now let's move on to the next example. This one's a little weird. Looks like we have a plus sign and we have some parentheses. I would probably say something like 5x times the quantity of x plus 4. Just trying to signal with my language that it's all of x plus 4 that 5x is multiplying with. So now I'm not just multiplying with a single term here. Now I'm multiplying this 5x by something with two terms, two numbers adding and subtracting. This is when we see the multiplication passing out. We learned that you could multiply with a group of terms, a group of things adding and subtracting, if you pass out your multiplication. So we can start by passing out 5x to x. And remember, as we pass out here, I'm talking about multiplication. So 5x times x. Well, there's only just one coefficient, so it's going to be 5 something. 5 what? Well, I have an x times an x. And just like we saw in the last problem, if we have a repeated factor, we use exponents to represent that. I'm going to end up with 5x squared. But I'm not done yet. The 5x needs to pass out to the entire grouping. So I'm going to continue that multiplication and multiply 5x times positive 4. Hear me when I'm multiplying, I read that as positive 4. So 5x times positive 4 will give me positive 20 with an x just shoved up against its backside. I just have a single x in that act of multiplication. So no exponents there. Lovely. Now a lot of students would want to keep going here. They see that plus sign. They're like, Kate, I want to add for you so badly. But remember that in the land of algebra, we can only add and subtract like terms. This is an x squared term. This is an x term. There's nothing more I can do here. I am done. Today, the examples that we're going to look at will involve both multiplication and addition subtraction. And so it's going to be very important for us that we're able to really have in our minds, what am I doing right now? Because really the processes that we use differ depending on what I'm doing, whether I'm multiplying or I'm adding and subtracting. So there's something I want you to notice about multiplying two-digit numbers. Now, I'm going to multiply this by hand instead of in my calculator, and I'm going to do it the traditional way that is taught in most, at least US-based schools. And the point of what I'm doing is not so that you memorize how to multiply by hand. It's certainly a nice skill, but not super important to the GED. The point is that you notice a pattern, because what I want to show you is what we've always done is what we're still doing. It might look a little different in algebra, but it's the same process. I really want to examine what happens when we apply that old multiplication algorithm that our third grade teacher, Miss Johnson, taught us. I know I'm always talking bad about Miss Johnson, but she had some very lovely qualities. She taught you how to do multi-digit multiplication, and she probably fed you cookies. Okay, so 32 times 21, we would line up like this. And then she would have us start multiplying with this 1, right? And then what would we do? First, we would multiply 1 by
2.
2, but we weren't done yet. It's not like adding and subtracting where we only did it in rows, right? We kept
Right.
on passing out. The next thing we did was take that same 1 and multiply it by the 3 in 32. We said, oh, if I take that 1 and I multiply it by that 3 tens, it's a 3, yes, but it's 3 tens because it's in the tens place, then I will end up with 3. 3 what? 3 tens. And so I would just put that 3 in the tens place. And we passed out that 1 to every digit in the other number. And then we weren't done, right? Then we had to pick up the next digit. In this case, the 2. Now, we know that's not really a plain old 2. That's a 2 in the tens column, right? So that's 2 tens. But still, we would take those 2 tens and we would multiply them
By 2.
by 2, the 2 in the first number. And so 2 times 2, or 2 tens times 2, gave us 4 tens, or 4 in the tens column. But we weren't done with that, right? It wasn't just one act of multiplication. You had to pass out that 2 to every digit in the second number. And so we would multiply again. We would say, well, now let's do that 2 tens times 3 tens, right? Our 2 times 3, and we would get 6. 6 hundreds, so that 6 would be in the hundreds place. And we passed out every digit in the second number to every digit in the first number. And that was our first part of multiplying. And then we did something interesting when we were done with that. Even though we were finished multiplying, we weren't finished with our multiplication process, were we? There was something else to do. What did we do next?
Well, now we're going to add.
We added while multiplying. Isn't that interesting? Yeah, we multiplied in pieces, didn't we? And then once we were done multiplying in pieces, we took the pieces we had gotten and we add them together. And notice what happens when we add. When we add, we didn't pass out, did we? We added ones with other ones. So we would start here and we say, oh, there's nothing else to add 2 with. 2 is the only thing in the ones column, and so I still just have 2 ones. And then we move on over to that tens column. We say, well, we have 3 tens and we have 4 tens. We can put that together for a total of 7 tens. Awesome. And then we said, well, hey, I have a 6 in the hundreds column, and it's my only hundreds, and so I just have 6 hundreds. And then my final answer was some number of hundreds, 6 hundreds, some number of tens, 7 tens, and some number of ones, 2 ones. I'm going to just say we added the same kinds of things. In this case, and with our plain old regular number, our kinds of things were our place values, tens with tens, hundreds with hundreds, ones with ones. Okay, beautiful. So my argument, Annette, is we are going to do exactly this today. It's going to look a little different. We're going to organize it a little different, but we're going to do the exact same process. We're going to pass out, and then we're going to add up the same kinds of things. Let's give it a try. We're going to compare this to multiplying not 32, but 3x plus 2. And not 21, but 2x's plus 1. Now, this is called multiplying polynomials. Poly just means many. So what I'm saying when I say polynomials is I'm talking about my groupings with multiple terms. Like having a 2-digit number, that's a group with 2 terms, a 3x and a 2. And that's a group with 2 terms, a 2x and a 1. So I'm going to start with my first term, not my first digit, my first term. And I am going to pass it out, much like we did last class with our distribution, to every term in the second grouping. And we're going to be real cautious. We're going to go one at a time. So let's start with 3x times 2x. Well, we know to multiply together the coefficients, the numbers out front first. 3 times 2 is 6. And then we know when we have more than one x multiplying, we have an x and another x here.
X squared.
Brilliant. And now we've passed out 3x to 2x, but I am not done with that term yet. Just like when we were multiplying before, it's got to pass out to every term in the second grouping. So boom, I'm going to take that 3x, I'm going to multiply with it one more time. Now I need to do 3x times positive 1. Hear me read that as positive 1 when I'm multiplying. So 3x times positive 1, well, nothing changes when you multiply by 1, so I'm just going to get positive 3x. Now, Just like when I was multiplying by hand and I had finished passing out one of the digits, this is done now. I passed out that term to every term in the second grouping. However, I haven't dealt with this term yet, the positive 2. That needs to be passed out as well. So we'll do positive 2 now times 2x.
Or shall we put an X on there?
Yes, there's just a
Yes.
single solitary x multiplying.
Okay.
It'll still be there. Now, if I had 2x and 2x, then I'd say 4x squared. But
Where?
I only have the 1x here, so I have 1x in the answer. And I'm not done with that yet. I'm not done until this 2 passes out to every term in the second grouping. So now I'm going to do positive 2 times positive 1. Positive 2 times positive 1. Remember, you're multiplying right now.
Positive 2.
Beautiful. Now, some people will teach you that this is called foiling. It's not called foiling. All right. We're still distributing. We're passing out every term in our first grouping to every term in our second grouping. But if you've been taught the term FOIL, that's fine. It's a way to help you remember that when you're multiplying, you're going to pass out first to first, and then outside to outside, and then inside to inside, and then last to last. If it helps you to remember, that's fine. There's nothing wrong with it. I don't say FOIL because I don't like rules that expire. I don't want a different rule for when it has 2 and 2 than when it has 2 and 3, or 3 and 4, or basically walk away with no matter how many terms are in the first grouping and the second grouping, as long as you pass out every term in the first grouping to every term in the second grouping, you're going to be okay. Now, look at my answers, though. Do you remember when we were multiplying multi-digit numbers? After we were done with the multiplication, we had multiplied in pieces and parts. And so any of those pieces and parts that could add together, we added together. Now, in our original example, we had 2 10s that could add together. And we see the same thing here. We only see one x squared term. And in this example, we only see one constant term, one plain old number. But look at this. There's some like terms. I have 3x and 4x, and we know that we can add when we have the same kinds of things. Just like we could add 10s and 10s, we can add x's and x's. And so we get plus 7x's.
Sometimes I get confused with the multiplication and the addition.
A bingo. And that's totally why we're going to do this real slow today, because that's exactly the skill. We're not doing anything new. We've multiplied, we've added. But today, we're putting the two skills together, which means you have to be able to flip back and forth between the two playgrounds in the same problem. That's a lot to keep track of. So we're just going to practice that repeatedly today until it feels a little more fluent. But I do just want to go back and compare that to the answer that I got when I multiplied 32 by 21. You know, this time I have 6x squared. Last time I had 600. And I have 7 x's. I had 7 10s. And I have 2. I had 2 1s. It's the same thing. It looks a little different, but it's the same thing. So the main thing that I want you to walk away with today as we multiply polynomials, groups of terms by other groups of terms. As we do that, the first thing to know is you pass out multiplication, just like we saw last class, it passes out. And now we're just seeing more passing out because we have more terms. Every term in the first grouping has to get passed out to every term in the second grouping. And that's our multiplying. But just like when we're multiplying multi-digit numbers in parts, when we're done, we have to combine or add, subtract. We're going to combine like terms. X squareds with x squareds, x's with x's, ones with ones, and so on and so forth. So let's look now at this example of multiplying polynomials. Now, these do happen to be binomials, bi meaning 2, so they have 2 terms each. But nonetheless, we said no matter what kind of polynomial we were multiplying, we would multiply every term in the first grouping with every term in the second grouping. And we will just start from the very first one. And I'm going to pass it out to every term in the second grouping. And we've got to keep in our minds right now, we are multiplying. And so I'm going to say that to myself. M times M is what?
M squared?
Beautiful. 2 factors of M multiplying. We see exponents when we're multiplying. That's when we see the M's start getting those exponents on them. Now we're going to do M times positive 7.
7M?
Exactly. It's just positive 7m. Now we're done passing out the m. We're going to pass out the next term. Make sure when you're multiplying, you read those signs as positives or negatives. So we're going to take a positive 5 and pass it out and multiply with m. So it is positive 5 times m.
Positive 5m.
Brilliant. Not done yet. I need to make sure that positive 5 passes out to every term in the second grouping. So now we'll do positive 5 times positive 7.
Positive 35.
Brilliant. And now I passed out my positive 5 to every term in the second grouping. Now I'm done. I'm done though with the multiplying, just like when we were multiplying multi-digit numbers. If we multiplied in parts, we then had to put our parts together. So we're going to do the same thing here. Are there any like terms I can combine?
Yes, 7m plus 5m.
Brilliant. Positive 7m plus 5m. And super important to keep in mind right now. Now we're adding. We're not going to see m squareds popping up, right? You put together m's with m's, you still have m's. When you type it into your calculator now, if you're going to use your calculator, make sure you do 7 plus 5, 12. And then you have to keep track of the fact that if you're gathering up m's and m's, you still have m's. We only see those exponents change when we multiply.
That wouldn't make that m squared because there are two m's? Okay.
Only when you multiply. The variable portion never changes when adding and subtracting. M's are M's are M's. That's why we can only combine like terms, but we can multiply with anything we want. Now, taking a look at this, we combined our middle terms. We have those positive 12m, but there's no other m squareds, and there's no other constants, plain old numbers. So those will just drop, and I'm done. Example 2. This time we have the quantity of 2x minus 4 times the quantity of x plus 1. See those groupings shoved together with only thing between them being parentheses? That whole polynomial is multiplying by this whole polynomial. All right, let's just go one term at a time, starting with the first term in the first grouping, 2x. And I'm going to start passing it out. So first we'll do 2x times
X.
Beautiful.
2x squared.
Gorgeous. Now I'm not done with that 2x yet. I still need to multiply 2x by
1.
positive 1. Brilliant. What is 2x times positive 1?
Positive 2.
Positive 2.
X.
X. Brilliant. Cool. I finished multiplying with the 2x. Now it's time to pick up the next term. Now listen, when I multiply, I'm going to read that as?
Negative 4.
Exactly. Negative 4 times x is what?
Negative 4x.
Good. So now as I read the next thing I'm going to do, I read that as negative 4 times positive 1. And I can do it in my calculator if I need to. So what is negative 4 times positive 1?
Negative 4.
Exactly. Okay, so let's get this into your notes. In the first step, we're multiplying. And when we multiply, we pass out. Coefficients multiply. And then we use exponents for repeats. Now that I've finished multiplying in pieces here, it's time to put together any of the pieces that can combine. I have positive 2x and I have negative 4x. Now I'm adding and subtracting. So when you add subtract, it doesn't pass out. You know, you can only combine like terms. And yes, you add subtract the coefficient, the number out front. But we see the variable never changes. You're not going to see the letters change. So as I do positive 2x minus 4x, hear me read it as minus now, not negative. So type it into your calculator. What is 2 minus 4?
Negative 2.
So I have negative 2, and notice no change to my variable. I'm adding, subtracting. So I drop my minus 4, I drop my 2x squared, and I'm done. Okay, let's read this. It says simplify. Okay, generic directions. What do they want me to do? Well, we've got to check out the symbols to tell. I can see this entire grouping is multiplying with this entire grouping. So I'm going to use some language to tell myself it's a grouping. I'm going to say the quantity of 4y minus 3 times the quantity of 3y minus 1. And as we multiply, we will go term by term. So let's start with this first term in the first grouping and pass it out to the first term in the next grouping. What is 4y times? Tell yourself times every time. So 4y times 3y.
I have 12.
I agree with your 12.
Y squared?
Bingo. Right now we're multiplying. When we're multiplying, that's when we see those exponents for repeated multiplication. Now let's do 4y times -1.
-4.
Good.
Y?
Bingo. We were multiplying with a y. There's still a y in there. Just a single factor of y. We're done passing out the 4y. Now look at that first grouping there. The next term,
Okay.
make sure you take its sign with it, is
-3.
bingo.
-3 times 3y.
Bingo. It has to get passed out to every term in the second grouping. What is -3 times 3y?
-9y?
Beautiful. Now we passed out our -3 to 3y, but we need to keep going until it multiplies with every term in the second grouping. So now we'll do -3 times -1. Say that times to yourself so that you make sure you don't type minus.
I got a +3.
Beautiful. And so I write +3. Cool. I finished passing out my multiplication, doing my multiplication in parts, but now it's important to combine any of those parts if any of them are like. We're going to deal with our addition, subtraction. Do you see any like terms?
The -4y and the -9y.
Beautiful. And now we're adding subtracting. So as you type it into your calculator, say -4 minus 9.
Which is -13.
Good. And now we're adding subtracting. So wiser, wiser, wise. Don't suddenly slip into exponents. It's not multiplication.
Now we bring down our +3, and we'll also bring down our 12y squared.
Gorgeous.
And there's nothing else for us to do.
Bingo.
I'm one of your B students.
No, you just graduated to A student, girl. She's an A plus.
Actually, I'm one of your C students, but okay.
No way, not you, Miss Annette. You work too hard. If you had a C, you'd be up in my office hours like, no, you will teach me that again, woman. Let's look at this next example. So nothing more challenging here. I just want to show you something cool that happens with an example like this. We're going to do the quantity of 5p plus 1 times the quantity of 5p minus 1. What's my first term in the first grouping?
5p.
Awesome. So I'm going to take this 5p and I'm going to multiply it to every term in the second grouping. So let's start with,
Well, 5p times 5p is 25p.
I agree with your 25.
Squared.
Bingo. When multiplying, use exponents for repeated factors. Now we're going to do 5p times -1.
-5.
Good. 5 times -1 is -5, but that wasn't just 5, that was 5p. So I'll have -5.
P.
So I'm done passing out the 5p. Now it's time to move on to the next term in the first grouping. What's the next term in the first grouping, Annette?
A +1.
Good. And this +1 has to pass out to the next grouping. So let's start here. +1 times 5p.
5.
What is +1 times 5p?
+5p.
Beautiful. And now we will pass out the +1 to the
-1.
-1. Beautiful. What is +1 times -1?
That is -1.
There we go. Do you see any like terms?
-5p plus 5p.
Beautiful. Now you can do that in your calculator if
Gives
you'd
me
like.
0.
It would be 0. That's why I wanted to do this little problem with you. It's going to be no p's. They're just going to go away. If you have no p's, you don't have to brag about it. Like, we don't have to walk around telling everybody, I have no fire coming off of my head. It'd be like, all right, Annette, good.
Okay.
I have no p's. All right, well, then they're just gone. So what do I have left?
We have the 25p squared, a -1.
Good. Okay, so I did want to show you this example just so you can see that sometimes terms cancel out. I have no p's left, and that's fine. It happens. Example 5. Find the product of a plus b and a plus b. Why are we experienced now? Because I slipped it in a word problem. Now I know what you're thinking. You're thinking, Kate, This is multiplying polynomials day, so I know they're multiplying, but it won't be multiplying polynomials day when you go to take your GED. So you better remember that this word product means a multiplication expression or its simplified answer. What are they asking us to do? They're asking us to take A plus B, that whole thing, and multiply it with another A plus B, that whole thing. So the first thing I'd like to do is write this in the language of algebra. If I want to take A plus B, that whole thing, and multiply it, I need to put that whole thing in parentheses. And I'm going to group it and multiply it by that next A plus B in parentheses. So there is the product of A plus B and A plus B written completely in math symbols. Now that it's written this way, I can just let that skill of multiplying click in like we did in the last example. I will start with the first term in the first grouping, and I will pass out my multiplication. A times A.
A squared.
Bingo. Now, we haven't seen this before in this context, but it's not too bad. If I want A times B, those are two mystery numbers I don't know. And so the best I can do is say, hey, that's going to be positive A and B shoved together. And now I finished passing out my first term.
Okay.
Time to move on to my next term.
Positive B times A.
Beautiful. Now I have to tell you something important, so put this in your notes. So when we're multiplying, we write the variables in alphabetical order. So if I'm doing B times A, I could write it as BA, and that's correct. It's just not normal. We usually write it in alpha order, AB. What is positive B times A? It's positive AB. And there's a reason why. It's so you can recognize like terms, because an AB is the same as a BA, and I don't want to miss like terms. You wouldn't be wrong to write BA. You'd just probably mess up the next step. And now I need to take my positive B and multiply by my other positive B here. So positive B times positive B is
B squared.
beautiful. And now that's why I wanted you to write them in alpha order, so you can notice now that it's time to add and subtract, those are like terms. If you wrote one as AB and one as BA, you might not recognize that they're the same thing. So it's just a good habit to write it in alpha order. So I have an plus AB, and that's a little tricky to type into your calculator. Like, what am I even talking about? Now's when we need you to remember the invisible coefficient. As you know, if there's no number out in front, it's a 1. Yeah, so we have 1AB plus another 1AB. We have a total of
2.
Exactly. 2 ABs. There's no other A squareds. There's no other B squareds. They drop, and I'm done. Example 6. Again, we see this simplify language, which is kind of generic, so we better be able to read the symbols. This time I see the quantity of x plus 4 times the quantity of x squared minus 3x plus 11. Now, I'm going to tell you the truth. You'll probably only see binomial times binomial on the GED. You probably won't see binomial, 2 terms, times trinomial, 1, 2, 3 terms. It's like when your multiplication gets a little harder in elementary school. But what I want to point out to you is this might be harder than what you see on the GED, but it's the exact same thing. And you need it for college. You need to understand this idea that multiplication passes out. So let's give it a try. So once again, stay really, really neat. I'm going to start with my first term in my first grouping, and then I'm going to pass it out to every term in my second grouping. This time there's 3 terms, so it's going to get passed out 3 times. It's the only difference. So let's start with first term times first term. So x times x squared. Now remember what x squared means. It means I already have 2 x's multiplying. So if I come and multiply by another x, now I'm going to have x.
Okay, 1, 2, and then, okay, x cubed.
Yep. Now we're going to pass out that x to the next term, x times negative 3x. Well, I only have the one coefficient, negative 3. And now x times x, that's x squared. Awesome. Now, I'm still not done with that x, though. I'm not done with that x until it passes out to every term in the second grouping. So now I'll do x times positive 11. X times positive 11 is?
Positive 11.
Positive 11x. Okay, wonderful. Now I'm done passing out the X. He's done, but I need to still multiply that
My
positive
4.
4 times every term in the second grouping. So let's start with the first term. Positive 4 times x squared is
Well, it's 4.
4x squared. Now I'm going to multiply that positive 4 times the next term. Positive 4 times negative 3x. Exactly. Positive 4 times negative 3 is
Negative 12x.
brilliant. I was multiplying with an x. I still have an x. Now I'm going to do positive 4 times positive 11.
Well, of course, that gives us 44.
Good. Positive 44. Gorgeous. Now we finished all that multiplying in pieces and parts, but now, just like when we do multi-digit multiplication, we have to add together any of the parts that can go together, right? So I do see some x squareds and some more. I see some x's and some more x's. So I think I'll start with the x cubed term. It's the only one, and so I'll see x cubed. But for my x squared terms, I have this one and I have this one. So I have negative 3x squared plus 4x squared.
1.
Good. Positive 1 or negative 1?
It is a positive 1.
Good. So you have technically positive 1 x squareds. But there is a symbol here I do not need. I do not need a coefficient of 1. So now I dealt with my x cubes, I dealt with my x squareds. Now it's time to deal with my plain old x's. I have positive 11x minus 12x. What is 11 minus 12?
Negative 1x.
Good. It's only when multiplying that we see those variable portions change. Now look at this though, negative 1x, there's a symbol I don't need. What symbol don't I need?
Get rid of the 1.
Bingo. All right, I dealt with my x's. And now as far as my constants, my plain old numbers are concerned, there's just the 1. And so I'll write
Plus
4.
44.
Good. And now this might look long and ugly, but that's as much as I can do. Go home and drink your tea. No more like terms means no more combining.
Let me tell you something. When I do go and take that test, I'm going to hear you.
That's what I want. I even say that in the math ability videos, like every time. I'm like, I'm trying to put my voice in your head. Sorry, not sorry. You know, like example 7, simplify. And this is interesting. It looks different, like we're doing something new. We see the quantity of 6k plus 5 squared this time. Now, I want you to be really careful. You cannot distribute a square. We don't distribute squares. We distribute multiplication. So don't think of it that way. However, we do know how to rewrite exponential expressions as repeated multiplication. Do you remember how if we had an exponential expression like just 5 squared, we said, oh, hey, we could rewrite that as 5 times 5. It doesn't matter how ugly the thing is that's being squared. We can still rewrite like this. So no, this isn't just 5 being squared. It's 6k plus 5, that whole thing. That's what the parentheses tell us is being squared. But we can still say, oh, that's the same as that whole thing multiplying twice or multiplying with itself. And I mean, honestly, now that I dealt with that, this is exactly like what I've been doing over and over again. This is nothing new. So if I just rewrite this in expanded form, I can use this same concept. And I will do that. I will start with the first term, 6k, and I will start passing it out to every term in the next grouping. So 6k times 6k is
36.
k squared.
Okay, we're multiplying. So then I'm going to use the exponents.
Exactly. If I was adding 6k and 6k, I'd just have 12k. But I'm multiplying 6k and 6k. I see that exponent action. Awesome, but I'm not done with 6k yet. Now I have to multiply 6k by 5. So multiply together the coefficients. 6 times 5 is
30.
exactly. And then that little k just gets shoved on its backside. Awesome. I'm done multiplying with 6k. Time to move on to the next term. Positive 5.
Times 6 gives me positive 30.
But it wasn't just 6, it was 6k. So I'll have positive
30K.
Brilliant. And now positive 5 times positive 5. Now there's no K's. I'll just get
Positive 25.
gorgeous. Cool. Do you see any like terms we can combine now that we're done with our multiplication time for addition subtraction?
Yes, 30K plus 30K.
Brilliant.
Will that give us 60K?
It sure will. Nice job. No exponent change when adding, subtracting. So I get positive 60K. There's no other K squared terms. It'll just drop. There's no other constant terms. It'll just drop. Cool. So now we've seen this idea of multiplying come up in situations where we wouldn't even realize that it's the same problem unless we remembered how to rewrite them. Now this looks scary, but we're going to use a cheat method that enables us to do exactly what we've been doing all class. So take a little bit of notes here because I'm not actually doing this the forwards way. I'm going to do a guess and check method. Example 8. Factor the polynomial x squared plus 6x minus 16. So it's important to understand, in order to understand what you're being asked to do, what this word factor means. We've heard the word factor. I've used it again and again with you guys to talk about it as a thing multiplying. I've used it as a noun. But here they're not using it as a noun. It's not a thing. They're telling you to do something. They're using it as a verb. They're saying, factor this. Okay. But the two are related. I said when it was a noun, when it was a thing, it's multiplying. Well, when I tell you to factor something, I'm telling you to turn it into a multiplication expression. It is moving backwards from multiplying. Instead of multiplying numbers together, you're pulling what you think of as the answer back into a multiplication problem. For example, if I asked you to just factor 6, let's do it in arithmetic before we do it in algebra. I'm asking you to say, can you think of a multiplication problem whose answer would be 6? Well, yeah, I can. 2 times 3. And that feels weird to students because we always want to simplify. We don't want to go from 6 to 2 times 3. We want to go from 2 times 3 to 6. You know what I'm saying? But if I ask you to factor, that's what I'm asking you to do. I'm asking you to turn this into a multiplication problem. But now, if you look at this example, it was really easy to factor 6. A lot of us know, hey, 6 is 2 times 3. But now look at this polynomial they're asking me to factor. You might want to vomit a little bit because it says factor the polynomial x squared plus 6x minus 16. I'm guessing that one's not on a times table you have memorized, right? And so turning this back into a multiplication expression would be challenging without me teaching you a lot of skills. Now, I love to teach those skills. I am, in fact, going to do them in later books, but I'm not going to do them here because I'm going to cheat. These are always multiple choice on the GED. And so instead of working and factoring, I'm going to pick the answers and work backwards. I am going to multiply back. I'll show you what I mean. I am actually going to start with the answers. Look at what they are. They're multiplication expressions. X plus 4 times X minus 4. And I'm just going to guess them, multiply them through, and see if they match. So x times x is x squared. X times negative 4 is negative 4x. I'm done with the first term. Time to move on to the second one. Positive 4 times x is positive 4x. And positive 4 times negative 4 is negative 16. Awesome. So nice that I have the x squared term and I have the negative 16 term. But take a look at my middle terms. Negative 4 plus 4x. Well, if I have minus 4 plus 4, that's 0, right? We have that example of them canceling out again, and I just have x squared minus 16. Those two don't match. A is not the correct answer. So yeah, I'm just going to guess and check. So Ms. Annette, do you care to guess?
Well, let's go with B.
Sure, let's give it a try. So we are going to do x minus 4 times x minus 4. Let's multiply it out to check. X times x is x squared. So x times negative 4 is just negative 4x. When you want to multiply together a number and a letter, you just shove them together. I'm done multiplying with the first term. Let's move on to the next term, negative 4. So negative 4 times x is just negative 4x. And negative 4 times negative 4 is positive 16. Combine any like terms? And I do have those, negative 4x and negative 4x. So as I type that into my calculator, I'm going to type Negative 4 minus 4. And I get negative 8. Negative 8 what? X's. I have no other x squared terms. I have no other constant terms. There you go. Does this one match? Darn it. I have my x squared terms, but I definitely don't have a positive 6x. And I have a positive 16, not a negative 16. It is not B. Cool, let's try C. Let's multiply together these two factors, see if we get back to our original expression. Starting with the first term in the first grouping, I'll pass it out to the next grouping. X times x is x squared. X times negative 8, you just shove the number in front, the letter behind is negative 8x. Done passing out the x, time to pass out the positive 2. So positive 2 times x is just positive 2x. And positive 2 times negative 8 is negative 16. And now combine any like terms. Negative 8x plus 2x will give me negative 6x. There's no other x squared terms. There's no other constant terms. X squared minus 6x. Dang it, I'm so close. And that, why do I always make it D? What a jerk. If you guys were smart, you would start with my D and work up. It's like I want you to do all the multiplication every time. Okay, so super close, but watch the signs. This one is positive 6x. This one is negative 6x. They do not match. All right, let's try D finally. The quantity of x minus 2 times the quantity of x plus 8. So we'll start with x times x squared. Then we'll try x times positive 8, which is positive 8x. Negative 2 times x is negative 2x. And finally, negative 2 times 8 is negative 16. I got some like terms there to combine. Positive 8x minus 2x gives me 6x's, and it's positive 6x's this time. I only have the one constant, negative 16. I only have the one x squared term. There it is. Yay, that's the right one. Correct answer is D. Now, factoring's lovely. It's a skill you're going to need for college. That's why I said I will teach it eventually in another unit. But even if you never get to any more units with me and you graduate, get your GED long before that, you can still attempt these problems by guessing and checking and working backwards. So guessing the answers and multiplying them back together. Okay, last example here. This is beyond the GED, but I love it because I shouldn't say it's well beyond the GED. It's not well beyond the GED, but I've never seen this particular example in the GED that combines these skills. But every skill we're going to combine right now is on the test, so it's good review. Example 9. Find the simplified area of a rectangle with a length of 7n minus 1 units and a width of 3n plus 1 units. This is a little confusing for me. So the first thing I'm going to do is draw my shape. So they told me it is a rectangle. Let's draw that. And then they told me a length. It's a confusing length, but it's still my length. I have a length of 7n minus 1. They also told me my width. It might be a confusing width, but I know what it is. I can at least label my rectangle. 3n plus 1. Now, what have they told me to do or to find here?
Multiply?
Yeah, I am going to multiply, but how do I know that? It's because it says find the simplified
area.
Now, some of us know how to find the area of a rectangle. We just haven't memorized. Oh, I multiply length and width. Some of us are going to look at the formula sheet. That's cool too, because how does it say to find the area of a rectangle?
The area of a rectangle is area equal length times width.
Exactly. To find the area of a rectangle, you multiply together the length and the width. So, Annette, you were right. We're just going to multiply. So let me take the length and then multiply it by the width. We said that the length of our rectangle was 7n minus 1. It might be confusing, but that's what it is. So I'll replace the length with 7n minus 1. Now I want to take that whole thing, and multiply it by the width. What is the width of our rectangle?
3n plus 1.
Beautiful. And now it might look confusing, but my algebra skills just kick in. Like, all right, I don't know what n is, but I can at least multiply this out. And yeah, I can put a equals here. But the key here is that I can use exact same skills I've been doing. So let's start with 7n. 7n times 3n, well, I multiply together the coefficients. 7 times 3 is 21. And I use exponents for repeated multiplication. So 2n's multiplying is n squared. Now 7n times positive 1, I'll just get a positive 7n. Negative 1 times 3n, negative 3n. And negative 1 times positive 1 is a negative 1. And once again, I'm going to look for like terms. Now that I've finished with my multiplying in parts, I should put together any of the parts that are the same. So positive 7n minus 3n is positive 4n. There's no other n squared terms, it'll just drop. There's no other constant terms, it'll just drop. And so what's the simplified area of this rectangle? It's 21n squared plus 4n minus 1. And that is the important part. It is in square units, but that's not the important part. That's just me being an anal retentive mathematician. Honestly, I just want to say that if you are one of those stubborn people who insists on following me to the very end, even though you are a beginning level student, trust me, trust the process. Go back and finish that beginning level and it is fine. Now, if you really are experienced or you really are advanced, then tackling these experienced and advanced level problems is excellent. It does help you, as we saw with one of those GED style examples, the factoring one. It kind of gives you a cheat method for it. And it's really good college prep. But even if all you ever do of this skill is the beginning level, you are doing GED level math, okay? That's the further we get into working together, the more and more you're going to see beginning level be GED level. Okay, you guys, now comes the important part. You must practice alone. I do not care how brilliant you think that I taught that. Hopefully it was pretty brilliant. I don't care how easy it was when I did it. If you don't practice, your brain is going to recycle that neural tissue, those brain cells, and forget what we talked about. And then you will go to take your test and you will see these problems and you will say, all I can remember is that it was really easy when Kate did it. That's not what you need. So make sure you do your independent practice. If you are still really struggling and this was so hard, start with that math ability before you move on to the independent practice. Get that extra tutoring step like you would get if you had a private tutor. Right, you guys, so proud of you. Happy learning.